The next physical property of minerals is luster. What is luster? Luster is the appearance of a mineral's external surface when ordinary light falls on the freshly broken surface of the mineral, which means how the mineral surface reflects the ordinary light. For example, if I take this piece of chalk as a mineral, when ordinary light falls on this mineral, how it can able to reflect the light. For example, you see the difference between this pen surface as well as this piece of chalk surface. Here there is no reflection on the piece of chalk. On the pen, definitely we can able to find some kinds of reflection. Here one kind of reflection, here one kind of reflection, here some other kind of reflection. Such a way, various kinds of reflections can be seen on the surface of the minerals. Basically, there are two kinds of lusters. One is metallic luster, another one is non-metallic luster. Before the types of lusters, we have to ensure what is luster. Luster means the appearance of a mineral's external surface, which means how it can able to reflect the light, particularly ordinary light falls on the freshly broken surface. Again, we have to ensure why we have to choose freshly broken surface. If it is already broken, sometime the dust particles will be deposited. Then the mineral does not able to reflect the light as its own property. That's why we have to ensure before we are going to identify the reflection whether the mineral already broken earlier or not. If the mineral is broken freshly, then only it can able to reflect the light as its own property. Basically, there are two kinds of reflections. One is metallic luster, another one is non-metallic luster. What is metallic luster? For example, one is metallic luster. When a mineral looks metallic shine, when a mineral reflects light like metal, then it is called by the name metallic luster. Example: magnetite, hematite, limonite, iron pyrite, chalcopyrite, galena, pyrolusite, chromite, silomalane, etc. These minerals are going to reflect the light like metal. Metallic luster means shines like metal. Example, magnetite. Ore minerals are going to reflect the light like metal, except bauxite. Bauxite does not able to reflect the light like metal. Care should be taken. Not all metallic minerals, except bauxite. Bauxite almost similar to the piece of chalk. On the surface of the bauxite, we cannot able to find metallic shine. Other than the metallic luster, another one is non-metallic. Under this non-metallic luster, various kinds of lusters can be studied. Amongst the first one, vitreous luster. What is vitreous luster? When a mineral reflects light like broken piece of glass or broken glass, just look at the window, how this glass reflects the light. Just imagine, when we take a piece of glass, when we bring this piece of glass into the ordinary light, we are going to find a shine from the surface of the broken glass. That kind of reflection can be seen on the surface of the mineral, that is called by the name vitreous luster. Here, shines like broken glass. Example, quartz. Or even topaz, even calcite sometime. When the mineral does not able to reflect the light like broken glass, when it is amount is lesser than the broken glass, then it is called by the name subvitreous luster. As such, when magnetite does not able to reflect the light like metal, the amount is reduced on the surface of the mineral, then it is called by the name submetallic luster. The next one is silky luster. What is silky luster? When a mineral looks like silk, or when a mineral reflects light like silk, which means similar to silk cloth. When a mineral reflects light like cocoons of mulberry, which is cocoons means mulberry particularly, which is used to manufacture the cloth. When a mineral is going to reflect the light like silk cloth, then it is called by the name silky luster. looks like or shines like silk. Example, the mineral asbestos. Here we are going to find the thin threads or thin fibers which are appeared in the form of assemblages. When an ordinary light falls on the asbestos mineral, that reflects light like silk cloth or shines like silk. That's why we are going to use the terminology silky luster that can be seen from the mineral asbestos. The next one is resinous luster. What is resinous luster? When a mineral has lusters of resin, when the surface of the mineral reflects light like resin, when a mineral shines like resin. Example, opal. Opal is a mineral which belongs to the quartz group. The chemical composition SiO2 and n number of water molecules. When we take a freshly broken surface of that particular mineral that reflects light like resin, even amber can also reflect light like resin. The next one, pearly luster. When a mineral reflects light like pearl, the surface of the mineral, how reflects the light is an important property. When we open the molluscan shell, how the reflection can be seen inside of the molluscan shell, similar to the molluscan shell reflection, shines like pearl. That can be seen on muscovite mica. Or even biotite mica. Mica group minerals are going to show pearly luster. Even talc mineral can also able to show pearly luster. If we touch the talc mineral, that feels like soapy touch. When ordinary light falls on that particular talc mineral, that reflects light like pearl. Even biotite mica, muscovite mica, they are going to reflect the light like pearl. That's why we are going to use the terminology shines like pearl. Adamantine luster. When a mineral is having diamond like shine. Example, diamond. Even garnet can also show adamantine luster. How the diamond is going to reflect the light? We have to remember the similar kind of reflection can also be seen on the surface of the mineral, particularly even garnet. Garnet is a cubic habit mineral that denotes adamantine luster. There are basically 1, 2, 3, 4, 5, 6 types. Togetherly, there are 7 kinds of lusters are recognized. The last one is dull luster or earthy luster. When a mineral does not able to reflect light, then it is called by the name dull luster or earthy lusters. Mineral with no luster. Example, kaolin. Kaolin, bauxite, and there are various kinds of minerals which do not able to reflect the light, then it is called by the name dull luster or earthy luster. Just you see, this piece of chalk does not able to reflect the light. Even kaolin is also similar to this piece of chalk. Bauxite, though it is a ore mineral, it does not able to reflect the light. On the surface of the bauxite mineral, we are going to find dull luster or earthy luster. Thus, the property luster serves an important physical property in identifying minerals. After habit, color, streak, luster is the another important physical property in identifying minerals. The next physical property is cleavage. Before move on to cleavage, I will give you 2 fruits. One is apple, another is orange. Peeled off orange, which means the removed of outer layer of orange. Just assume, I do not give any fruits, but just assume. On this palm, apple is there. On this palm, orange is there. When I call you, any one of you, to give this fruit to share along with your friends without giving knife, how do you share? You apply the force and you are going to break that fruit, and that will be unevenly distributed. But when I give this orange to any one of you, how do you share? You can able to take slice. Each, when you are 4 to 5 members, you can able to take each one slice. Without giving knife, you can able to get it, but without giving knife you can't able to get the fruit apple. Then what did you find from the fruit orange? There is a planes of weakness along which we can able to remove slice. Here in the apple fruit there is no planes of weakness, which means certain crystallized minerals to show tendency, certain crystallized minerals are going to show the tendency to split along proposed directions, yielding more or less smooth surface. For example, from the orange, when we are going to remove the slice, on either side of that particular slice, we are going to find smooth surface. On the contrary, from the apple, when there is no knife to get the slice, when we apply the force to get the fruit, that does not able to yield the smooth surface. Which means the tendency of certain crystallized minerals to split along certain proposed directions, yielding more or less smooth surfaces, is known as cleavage. Cleavage means the tendency to split along planes of weakness. Only crystallized minerals show cleavages. Only orange or Mosambik fruits can able to show cleavages. But the same like the lemon fruit is having the partitions, but that does not able to show any planes of weakness. As such, all crystallized minerals do not able to show planes of weakness. Amorphous minerals do not show any cleavage planes. Apple-like minerals do not show any kinds of planes of weakness, like bauxite that does not able to show any kinds of planes of weakness, like quartz group, transparent quartz, milky quartz, rose quartz, amethyst, opal, rock crystal do not able to show any kinds of planes of weakness. The cleavages takes place along planes of weakness. From the fruit orange, we can able to divide the fruit along the planes of weakness. The cleavages takes place along the planes of weakness. The planes of weakness depends upon the arrangement of atoms in a mineral and are parallel to the definite crystal faces. There are various kinds of cleavages can be seen, which are explained by different terminologies like basal pinacoidal cleavage or basal cleavage, prismatic cleavage, non-cleavage, cubical cleavage, rhombohedral cleavage, etc. Amongst, let us take one by one. The first one is basal cleavages. What are basal cleavages? Here only one set of cleavages and the direction is parallel to the basal pinacoidal phase. For example, if it is the mineral, here only one set of cleavages can be seen in this direction, which is parallel to this basal pinacoidal phase. That can be seen in muscovite mica, biotite mica minerals. Basal cleavages means one set of cleavages. Example, muscovite mica. How do we define? Here only one set of cleavages in one direction. This is the only one direction. We do not find other than this cleavage plane. You see here, this is the only one direction cleavage. This is the cleavage plane. It can be separated along this cleavage plane. And the direction is parallel to this phase, basal pinacoidal phase. The next one is prismatic cleavages. Here, two sets of cleavages example, hornblende. Hornblende is a magnesium iron silicate mineral which is an important rock forming mineral. Here we are going to find prismatic cleavages. There are two sets of vertical cleavages. Here one set of horizontal cleavage. Here two sets of vertical cleavages. The cleavage planes are parallel to prismatic faces. If it is the mineral like this duster, one set is in this direction, another set is in this direction. This is the prism phase. These two sets are vertical in nature. In the first case, in the basal cleavages, the cleavages are horizontal in nature. The next one, the third one is cubical cleavages. Here, three sets of cleavages. To show the cubical cleavages, the minerals must have obtained cubical habit. For example, if it is the mineral, we are going to find one set of cleavages in this direction, another set of cleavages in this direction, front to back one set, left to right one set. These two sets are always vertical in nature, another set is horizontal in nature. There are three sets of cleavages and they are at right angles to each other. To show cubical cleavages, the mineral must have obtained cubical habit. Otherwise, the mineral does not able to show cubical cleavages. That can be seen from the mineral galena. Galena mineral has 3 sets of cubical cleavages. One set front to back, another set left to right, another set horizontal in nature. Such a way, the mineral has cleavage planes, planes of weakness in all the 3 directions. When we break that particular mineral, each particle is going to show cubical habit. That is the important property. The next one is rhombohedral cleavages. Here also 3 sets of cleavages can be seen. One is front to back in vertical direction, but another one is left to right, again vertical direction. Another one is horizontal direction. Here also we are going to find 3 sets of cleavages in which the cleavage planes are not right angles to each other. In the earlier case, which are mutually parallel to each other, which are right angles to each other. But in this case, which are not mutually parallel to each other, which means other than right angles to each other. That can be seen, particularly the mineral which belongs to carbonate group like calcite, dolomite, etc. When we break this mineral into hundreds of pieces, each mineral is going to obtain rhombohedral habit. To show rhombohedral cleavages, the mineral must have obtained rhombohedral habit. Otherwise, the mineral does not able to show rhombohedral cleavages. The last one, non-cleavages, no cleavage planes. When there is no planes of weakness in any mineral, then it is called by the name non-cleavages. That can be seen from the mineral quartz group. Even amethyst, rock crystal, opal, chalcedony, jasper, milky quartz, rose quartz, agate, whatever the mineral which comes under quartz group, they do not able to show any cleavage planes. There are basically 5 kinds of cleavages: basal cleavages, in which only one set of cleavages. The second one, prismatic cleavages, there are 2 sets of cleavages. Cubical cleavages, there are 3 sets of cleavages in which all the cleavage planes are at right angles to each other. Rhombohedral cleavages, again there are 3 sets of cleavages which are other than the right angles to each other. Non-cleavages, there is no cleavage planes.